when Tim asked me to do a quick presentation about triumphs and challenges, I figured I added that it's a triumph or challenges of data of amateur data scientists, data analysts. When I started, I'm kind of like a Mark. I'm a geophysicist, and when I started looking into what else besides geophysics I can do, I was lucky enough to be part of a course that was offered by Robert Gardner in conjunction with university. And we learned a lot of different algorithms, machine learning algorithms and tools, but we had to do a capstone project and I wasn't sure what data to choose because I could not do new data and new algorithms. So I decided to use, some of you probably seen this before, Matteo used to post on his LinkedIn some of the this data, and he was trying to predict faces. So I thought, well, I'll use new tools and apply them to the data I already know. And then, so I used this 2016 web correlation competition data. And then what it is 9 wells, and they all have this 5 curves. And then they have information about faces. And then they also have another set of wells, and you try to predict, and then you try to validate your data. And what I also noticed, there's 9 wells, but only 7 of them had this PE log. And PE log, usually humans can determine faces without having the PE log, but for machine learning, it seemed like it would be a really nice additional tool because it helps you to identify specific mineralogy. And I've seen another presentation during GeoConvention in 2019 by Marcelo Guarido. And what he did, he modeled this. So for me as a geophysicist, I thought, okay, I know how to do inversion. I didn't understand modeling. It's kind of creating a synthetic. So I understand this and I can use new tools to do this. Then what helped me to understand this data is being subject matter expert, using new tools toward the data that I already understand. And then when I looked at correlation matrix, what I noticed is that something like a GR, right, negatively correlated. And if I didn't know anything about what those tools are, I would probably just discard some of those features that negatively correlated to have very low correlation. But because I worked with this for the last 10 years, I was like, okay, this is something that I have to use. So that kind of helped me to be a subject matter expert. And then I used Marcelo's sort of idea to create synthetic, and then I used a linear correlation. I looked how well it is correlated. It predicted my new calculated P. I compare the existing one with my synthetic one. It looked pretty good, and so I applied it to the whole data set. So sort of I learned a lot during this, and what really helped is, like Mark said, it's not about tools, it's about people, and it's about understanding what data says. Another way I started using data is I looked at what if I can use different visualization tools like Tableau. And at that time, when I was looking at learning how to use Tableau, Tesla, their stock split 5 times. So they went from 1,500 to 500. And I was wondering why, what happened? And then so I decided to load some data from their wiki page, and I looked through the company. I know reports, but it's kind of hard to find data. And then what I looked is, okay, so they split. What happened in the past? So in the past, this is where their manufacturing facilities are all over the world, basically, and they're opening up a new one in Germany. So then I looked in the past. Okay, so they were making, they're making models and then selling them, and they're usually selling just as much as they're making. And then you have total production in yellow, sales in blue, and orange, and transit. So, okay, so they're making exactly what they selling exactly what they're making. So, and then I thought, should I invest in this company or not? And this visualization really helped because now I'm using new tools, new analysis. And then basically what happened is when I look at it, they are planning to make new models, and that's probably why they split the stock, and that's probably why they're trying to raise more money. So that's sort of, I was trying to use my knowledge to apply to something else. And finally, I was trying to summarize what triumphs and challenges I had over the last year and a half as I was trying to transition from being a geophysicist more into data analysis. And what I really found out that there's a huge group of people in Calgary and outside of Calgary that really interested in it. They're very supportive, and they're very sharing people, very generous, and really like to be part of this community. And first time when I heard a presentation about artificial intelligence, it was by CGG people, and then I thought, what are they gonna make robots pick up seismic data? And then AI also, I always think about it as Steven Spielberg had a movie about AI. And then when I saw the presentation, I was like, okay, this is all doable because all they do is just use statistical methods and computing power, new computing power to calculate something. So it is interesting and doable. And then I found this new calling in data analysis and data visualization. And a couple challenges, like that, to summarize, the bigger challenges that I found is that unfortunately there's quite a few people that kind of looking for unicorns, while we have a lot of really good people in this group where they are ready to do the work if somebody gives them a chance. And it's really sometimes hard to keep up with new tech developments because we have more and more tools coming to the market, and trying to decide which tool to use is a bit of a challenge, but it's kind of a good learning experience. So that's with that. Thank you very much for giving me this opportunity.
A lot of companies are looking for those unicorns. Today's topic, landing a job in data science. And it is one of the more unfortunate things. Now, we see more of this request for the unicorn data scientist with more startup to medium-sized companies. And what I mean by that is the challenges that a lot of our candidates have with landing a position is they're wonderful statisticians, or they're amazing at creating the models and doing the algorithms and creating all that good stuff. But more and more of these clients seem to think that that same resource can do cloud computing or deploy and redeploy the models in a live production environment. So to kind of cap it off, that's the biggest challenge that I have found, is that companies do look sometimes for that unicorn. And I think that there needs to be a shift into breaking down full data science teams and not making it, and kind of getting away from this idea of one person to do it all. I think that is going to be critical, and that's what we're going to see more and more of. So I'll start with that, but I wanted to today take about 10 minutes to chat about actually the processes that we have seen clients take on when they go and hire a data scientist, and just some very high level things. And I'm going to dive into some specific examples as well with 3 different clients. All of them are Canadian and growing companies. So the first big key notice that everyone's going to kind of notice when they're applying to these is it's never just one round of interviews anymore. I have seen candidates do up to 8 or 9 interviews for these types of positions, depending on the company and what the company is looking for. But on average, you're looking at about 3 to 5 rounds. And within those rounds, you're going to see both functional business and HR resources, as well as the BI, business intelligence resources, like a data scientist or a senior BI developer of some sort. And they'll kind of include those resources along the lines of the recruiting process. And another big thing is you will be expected to do some coding in one way, shape, form, or another. This first example is a Calgary-based client that has about 5 to 6 steps. Usually it's about 6 steps to go through from the time we recruit a candidate to the time they actually issue an offer. And it starts with an assessment in Python or R to determine their development capabilities, their ability to wrangle data, cleanse data, that kind of stuff, working with SQL Server, sometimes working with NoSQL, depending on who the client is. So they'll start with the Python or R assessment, just to determine your ability to wrangle data, cleanse it, do the ETL processes. And then they'll do a very high level phone or video screening interview. This is normally all behavioral to get an idea of how you're going to fit from a cultural standpoint. From there, if you pass, then you move into a video interview with the hiring manager and the data scientist on site. It'll usually be a very senior resource, and it could be a panel. We've seen panels of up to 5 people interviewing a single data scientist, just because it's such an encapsulating role. It requires so much attention. Once that's completed and they feel like you're a fit and you've used the libraries that they require, at that point, they'll give you a coding assignment to take home with you. And usually there is a timeline of 1 week around when you can get that done. Now, they'll say something like, for this particular client, they said that it would take 2 hours. On average, it took the candidates that I sent 4.5 to 5 hours, because it included a great deal of cleansing the data and wrangling it before and actually setting up the environment to create a model. They're quite extensive. These assignments tend to be quite extensive. So once that's done, they'll have one more interview with you, with the data scientist, and usually it'll be another HR representative, but it'll be with the data scientist to essentially determine your thought process around creating the predictive model that you had created. So how you actually went about doing it, the models that you used, the technologies that you used, and depending on how well the model is created will be if they issue an offer or not. So that was my first client example. Now, to dive in a little bit deeper on the assignment itself, as I mentioned, they want a predictive model to be created, and they give you a pretty large data set where you need to go through and determine all the outliers and all the data that doesn't quite fit. And you guys would know more about that than I would. Another key thing that a data scientist actually said to me was, and I never quite understood this, so I apologize, you guys will probably run with this, but an environment must be first set up within Python. So the setting up of the environment for you to actually go ahead and create these models will take you a great deal of time. So if the assignment is timed, you need to ensure that you take that into account, that you're gonna have to actually set up the environment before you can jump into it. And then, yeah, to cap it off here for this one, depending on how complex the models that you are going to be creating will determine the amount of hours that it'll take. But on average, as I said, it took my candidates about 4 to 5 hours to complete this assessment. Once that's done, it's reviewed, and from there, they'll make a decision. But it is quite the rigorous process. And you're going to see that with a lot of these clients, that tends to be the case. This second client is based out of Toronto. They're also a growing company, and they have a somewhat shorter process. The first thing they do is they ask you 3 very specific questions that I'm going to share with you guys today. I recommend that you write these questions down, because something like this might come up. We do see these types of questions where they try to see if the data scientist, their grasp on the development world, and that's how I read it. And so if you're able to answer 2 of the 3 questions, 60%, they'll go into a behavioral interview and look at your high-level experience. It'll take about half an hour or so. From there, the third step is to interview with the HR and senior data scientist. They do a very technical interview and discuss code standards, scope of projects, everything from the type of data you dealt with to the technologies that you use to deployment to the team that you worked within. And then if they see fit, they'll issue the offer. So these are the 3 questions that they ask. And I was trying to figure out why they ask those 3 questions in particular. I think to me, it just shows that they're looking for more on the development side of things. So the first one is, what is the difference between SSD memory and hardware memory? And how do they work in respect to cloud? So you can see, again, they're looking at possibly deployment, more on the infrastructure aspect of how the model is going to work with the actual application. The second thing is the difference between a process and a thread within a programming language. So this processes and threads within programming languages could be C#, Java, Python. Most likely going to be within Python because it's the most notable data science language right now that's being used. And then the third question, what is the difference between REST APIs and RPC? And then example number 3. So for the third example, it's also a Toronto-based client. I was not able to get a hold of the specific questions that they asked. Hopefully I can share that with you guys next time around. But essentially it's a five-step offer where it starts with a phone screen. Again, it'll be more around the culture fit and your overall experience. From there, they'll do a video interview with a senior data scientist on site, and they ask you to actually do some live coding while you are interviewing. So through a shared screen or through some sort of program, they have you actually code so that they can review the thought process around your problem solving. From there, if you pass that step, a technical assignment is given to you, and they give you a 1-week deadline. And depending on if you're working full-time and kind of your situation, there is some leeway. But you'll notice that a lot of these companies, if you don't get the assignments in sooner than later, more often than not, they'll view it as a negative. So I guess the best advice I can give you is communicate that up front if you cannot meet that week deadline, because they will look at that and they do review that timeline. And then the fourth step is they actually review the models with an internal BI team as well as a senior data scientist. So in this instance, it's not just 1 or 2 BI resources. They have a full team that will review what you've created for them. And they're looking at, again, the methodology and your problem solving skills, how you actually went about to solve that problem that they had out there. I believe in this case, it will be a predictive model as well, but that I will have to confirm. And then an offer is issued.
I do have one question. Just quickly, it reminds me of a running joke that I saw recently that if the chef was treated like a data scientist, that restaurant would expect that person to also be a professional farmer, butcher, bartender, and server. Seems like there's a lot of expectation, right, around these roles so far. Do you think that these interview processes are a result of the current work environment, i.e. like there aren't a lot of jobs due to COVID? Or, I mean, the tech world seems to have very rigorous interview processes as well. Is that just data science roles kind of keying off that tech world?
Yeah, it's really unfortunate. I feel bad. I am still more on the business side of things, and I always say it to developers, data science. Like, I feel bad for the technical resources because they'll put you through the ringer. I had a gentleman do 9 interviews, 9, including technical assessments and things like that. So it is unfortunate, and you are right. That's a very good analogy and way to look at it. And it's a problem that I've had as a recruiter is you can't expect someone who's been a statistician that can create these algorithms to also understand infrastructure as code, you know, and things of that nature. I mean, you can, but at that point, you're looking at someone very, very senior, and it's really hard. I mean, those unicorns are out there, but they're few and far between. So the strategy that I tell our clients that we've been pushing for is to break out these jobs. You have a data analyst, you have a BI developer, you have someone that can wrangle the data and clean it, and then you have someone on the infrastructure side of things that can work on the deployment of the model. Whereas right now, as I said, and as you mentioned, Mark, they expect them to do it all, and it's just not realistic.
Khaled, there's a couple of questions that have come through the chat window. So do participating in hackathons, Kaggle competitions add to the value of a resume? And do your clients typically prefer someone with a portfolio of projects to share during the process?
A fantastic question. And to answer it, yes and yes. I harp on this all the time. The more that you can show upfront, the better chance you have. And that's, across the board, developer, UX, UI designers, data scientists, people that do visualizations, using Power BI or Tableau or, the Oracle suite or whatever it may be. Doing datathons as well, the more that you can share upfront, the better chance you're going to have across the board. So to answer your question, yes and yes. Those datathons are huge, and the portfolio, I would say, should be front and center on your resume.
He has seen a number of roles within Calgary that are posted over and over again. Do you know if these companies are filling roles, or are they having issues filling them due to high expectations? Or what exactly is the strategy around continually reposting a role?
Usually it's because they haven't found quite what they're looking for. It is, it's still a fairly new practice. When someone says to me, I want a senior data scientist, the most senior that I've seen that actual legit data scientist has been about 6 years. So what people need to understand is, okay, if that individual came from a development background, then potentially they can add more value as far as the deployment aspect of it. But to answer that gentleman's question, more than likely it's because they're asking for too much. That's been my experience. They're asking for too much. And these roles need to be separated. Realistically, they need to be separated. And I think from our client standpoint, that's what we've been telling them is, if you're struggling with it, you're either going to hire someone that's going to charge you $200,000 a year, $200K easily, or they're contracted at $130 an hour. They're real unicorns out there, and they work for Google, they work for Amazon. You know what I mean? They do exist, but they're in the top 5%.
So we'll move on to the keynote presentation now on landing a job in data scientist. And so Shahbaz Masih is the keynote speaker today, but we also get a 2-for-1, which is wonderful. He's also invited his hiring manager, Sushma, to come and join us. So if you do have any other questions that would be kind of directed towards Khaled, you can direct them towards her as well, and maybe she can help answer some of those. So Shahbaz is a PEGA registered professional engineer with an MSc from University of Regina and a BSc from the UET Lahore in Pakistan, both in petroleum engineering. He's currently working as a machine learning engineer with Intellius Analytics and pursuing a master's in data science from the University of Calgary in the evening program.
Hello, everybody. Thank you for joining today's presentation. I will just start with the brief overview of my presentation. So we will talk about first required skills, both soft and technical skills. And that's why I have invited one of our team leads, Sushma Shetty, and she will talk about required skills. Then I will move on to the approach to build technical skills. And I will just overview, how I attained the skills that I gained over the years and how I have utilized those in my whole journey so far. And then networking, it's very important. The more you do, the more people we know, the better it is. So networking is the key. Then building a portfolio, how we build a portfolio, as Khaled just mentioned, the more you can show the employers up front, the better it is. So I will just briefly go through the different aspects of a data science project, and then I will show you my own project, how I build it by following all those stages of the data science project.
So my name is Sushma Shetty, and currently I work with Intellis Analytics as a business manager and oversee execution of a number of projects here. So at Intellis where Shahbaz and I work currently, it's actually a startup, and we specialize in consulting services for data science projects. In my role, I often have to hire professionals for my projects, not only limited to data science projects. It could be, big data projects or some full stack development kind of projects. So Shahbaz asked me to speak about what we usually look for in candidates, especially when we're hiring for DS related roles. So that will be my focus of today's discussion. As far as the hiring process goes, every organization is different, right? The way they hire is different. It depends on how they are structured, how they structure their team. And it's also entirely dependent on their business or their area of expertise, right? So what I want to talk about is just based on my experience working in data science and big data related projects. So, and in no way I want to imply that this is exactly how every candidate is hired. And whatever the previous speaker mentioned about the hiring process is very true. We have the same experience on the hiring side. As the previous speaker mentioned, that we have normally candidates go through like 3 or 4 or 5 or even sometimes 9 rounds. In our case, it's not that rigorous. So I don't want to scare you guys. So in our case, we just have like around 4 rounds of interviews. The first one is just a typical phone screen, which is just based on what applications we receive from the job boards. So in that stage, I would say it is very critical to have a very impressive resume. So all the things that you can put in, all your achievements, your qualifications, whatever little things you've done, attended hackathons or whatever he discussed, all those things if you can put, because that's an eye catcher. So never ignore the contents of your resume, right? So it is the first place where it's the first thing that we look for. It is the seriousness, right, of the candidate when they're applying. If they've crafted their resume carefully, that shows that they're serious about their jobs, right? So making that first impression is important. So after we go through the phone screening, we usually conduct a technical test. Sometimes we don't. It depends on the projects that we're looking for. So on our end, we have had candidates come into the office when we had the office open, and we have given them a laptop and given them a simple problem to solve. Usually a mathematical problem is what is given. It's usually decided by the senior data scientists. The other things that we have done is we have also created tests on websites. Like one of the websites is HackerRank website, where we have created test questions and asked the candidates to complete those tests. After we just give them a duration, and based on their tests. So that's one way for us to shortlist very quickly. Now the thing is, people often feel like, oh, it's a online test, I can crack it, I can look for things and stuff like that. So remember, in HackerRank, at least in HackerRank, and I'm pretty sure it's pretty much the same in many other websites, they do flag copy paste. So you have to be very careful when you do those things. So, that's why skills in coding is important. So that's one way of shortlisting that we do. And then next is the technical interview round, where we have senior data scientists interviewing the candidates. So they go through their typical data science related questions. And then the next one is the HR interview, after which the offer is issued. So that's kind of the process. Now, On our end, usually whenever we hire in data science related projects, we usually have kind of like 3 categories of candidates. So we would often require senior data scientists. The second category is like junior data scientists or intermediate data scientists, and then the next category is of that of a machine learning engineer, which is what Shahbaz was hired for. So now, how we kind of come about hiring them. So for example, for senior data scientists, we call them thinkers. So thinkers meaning we need people who it's usually candidates who have a master's or a master's degree or a PhD. We look for candidates who have worked on a lot of real world scenarios, real world problems. So somebody who can translate, somebody who can tell us which machine learning solution is applicable to this business problem, right? So they can identify which kind of algorithm should we apply, or they can frame that business problem into like a mathematical or a statistical frame, right? So those are like senior data scientists. And then for the junior data scientists, we consider them as like long-term investments, right? So they are somebody who can grow with the company. So and they come up with fresh ideas, for example. So typically junior data scientists, we kind of put them with senior data scientists. So senior data scientists would lead them. So they come up with all the thinking and like a plan to approach the problem. And then the junior data scientists are there to implement, or they go through those experiments and so on. So they get into the nitty-gritty of the things. So usually for junior data scientists, we're looking at from the academic perspective, we're looking at bachelors in say mathematics or computer science or statistics, for example. And if they're not in any of these fields, even we have also looked at candidates who have had certifications, to complement those degrees, for example. So that's that. And then we have the machine learning engineer. Here is where you often see, we often see that Venn diagram, right? Where we have like a combination of skill set, like the computer science skill set or the statistics skill set and the data science skill set. So this, for us, a machine learning engineer would be somebody who has a passion for coding, somebody who can get their hands dirty, so who has interests in programming and even hacking, for example. So people who are passionate about, sitting on the computer and have a lot of experience or is passionate about coding, basically. So this role also, we usually look for people who have maybe experience in visualization tools, for example. Of course, Python or R or SQL, all these programming languages are a must in data science. So somebody who's very good at these things is what we look for. And then if you look at some of the soft skills that we have here on the slide, data, who has curiosity in the data. So you guys know it very well that right now, data is very critical to organizations, especially when they're in a competitive market, right? They want to stay one step ahead. That's why all this predictive programming and predictive analytics and things like that are hot in the market right now. So usually, because in my experience, almost 80% of the time is spent on data. 80% is spent on just data wrangling, cleaning data sets, transformations and stuff, or doing a data modeling exercise, for example, like finding relationships within the data, or data mining kind of work where, people are observing patterns and so on. So somebody who has a good hold on analyzing the data, exploring the data, designing the patterns, looking at the patterns and being able to give presentations on, okay, what are they looking at currently within the data? that's something that we usually desire. And then the business acumen or business analysis. So one of the things that when we have the candidates, when we have a new hire, for example, it's very interesting to see. It's very interesting to see that some people really get the business business knowledge very quickly, but there are some people who struggle with it. So it is very important that you pay attention to the business. So if you're entering into, let's say, an airline or a transportation kind of industry, so it's very important you do your homework even before the interview to get some kind of knowledge around the industry. Get that industry knowledge, because often you will face questions related to that industry, just to see if you can become comfortable in that business domain, right? And some other things are given, like communication is given. So because usually the data scientists will work with a much bigger team. The data science projects are much larger sometimes. From working with our clients, we know it's usually the team will be consisting of business analysts, will be having IT infrastructure team, will have management people in there, data engineers, user interface designers, and so on. So effective communication skills is important because you have to articulate your ideas or your results to them, right? And then, of course, teamwork. It's a given again that medium to large size companies, there will be multiple actors within the team. Now, the only one essential skill that I will tell you guys that I usually look for is we want the people to ask for help, because the last thing you want from a team member is that they are just trying to resolve the problem on their own, and they're taking a lot of time. So here, the project delivery is the key, right? So you shouldn't be taking too much time just trying to do all the research and development, because most often you can find help from, if not Google, you can find help from other team members who may have gone through that same problem. So ask for help, right? As for, those are some of the non-technical skills that we look for. And on the next slide, Shahbaz, we have some technical skills. So we, on the technical side of things, for sure, it actually totally depends on the project. We were talking about the unicorn candidate. For sure, every company is looking for a candidate that will have a skill set in data science, statistics, and computer science mainly. Also because right now the projects, they're tight on costs. So somebody having multiple skill set is usually desirable. That's the hard reality of it. So on the data science side of things, from the technical perspective, again, machine learning concepts, deep learning concepts, all these are given. At least when you go to an interview, the fundamental concepts should be clear. There will be questions on, especially the fundamental concepts, where we use decision trees, where we use boosting algorithms, for example. Those kind of things are essential. You have to know. Some of the other things I've heard from listening to technical interviews, they ask questions about, especially related to statistics, because you will need to know your distributions, probability distributions, those kind of things. How would you do a feature engineering, for example, those kind of things. So things like that would be essential. As for the tools, I mostly work on Microsoft related tools. So on our end, we use Azure services. So we use Databricks, Azure ML services, ML Flow. Any of these tools, if you know, they'll be handy, at least if you're looking at Microsoft related products. And then Python language is very essential. Python, SQL, R are some of the popular ones right now. Scala and Java are also in there. So from on our end, we use Jupyter Notebooks, PyCharm when we use smaller data sets. But when we use big data sets, then MLflow, Azure Databricks are some of the tools that we use. And on the data side of things, like I mentioned, SQL is a very handy skill set to have. Right now, since big data is the thing, most of the ML projects are based on big data. So let's say Apache Spark is, having knowledge of Apache Spark is essential these days. Other than that, it's very important that you present your results. Usually our data scientists are required to do a lot of presentations. So any visualization tool like Tableau, we have Plotly Dash right now, which is very handy for a data scientist. Even Power BI, I've seen people use Power BI as their visualization tool. So having knowledge in some kind of a visualization tool, throwing it in there and articulating your results will be very handy. So yeah, that's kind of in a nutshell what we see in a candidate, as well as what you would need to be prepared for.
Just roughly, what would be the split between the soft skills and then the technical skills in the candidates that you're looking for?
I can't answer this in terms of percentage, but when we give advice to our technical interviewers, right? The first thing we do is we say, make sure they are the right fit for the team, right? Because it's very important that when the candidate comes in, they fit right into the team, because there's often differences in opinion and things like that. So the first thing we need is, for the person to be a good fit with the team, right? Projects that are very difficult, where prediction is very hard, where we know that the projects, it'll be very harder, we do require them to have a strong statistical background, let's say, or strong skill set in the data science area, where the problem is not that hard, but then being able to manage it, to take it over. For those kind of projects, we look for the machine learning engineers. So I wouldn't say it's 50-50. The emphasis is still on the data science skills more than the non-technical skills. It depends on the project and the interviewers and so on.
So now, how to build these skills that both Sushma and Khalid have just described. So the approach that I have taken is, just leverage your background. It doesn't matter what it is. If it's a quantitative field like engineering or computer science or geoscience, maths, statistics, that's great. You have already nailed it, almost like 30% of it. And how to leverage those skills. Like as an engineer, I was looking at data all the time. I was analyzing the data all the time. Why I moved into data science is actually also because of an engineering project. I was a project lead in reservoirs with bottom water in Shetty, and there was a lot of data to analyze, and all I had was an Excel sheet. And luckily my neighbor, he was a geophysicist, and I used to ask him, pick his mind on geostatistical concepts, and maybe try to incorporate that in my analysis. But I was not very satisfied. So I always wanted to learn more about data analysis. So whatever your background is, just try to build on it. And then, the first time I was laid off back in 2014, I could not find a job for more than a year. And then I went to SAID and I took 8 months certificate in programming. And it was object-oriented programming, just like Python. So that has helped me a lot in learning Python. Same thing, if you are a geoscientist, like well logs data, geophysical data, you're looking at huge data sets all the time, and how you analyze those. So just try to build on it and attach different pieces to that, like maths and statistics that Sushma and Khalid just mentioned. They are also very important. Now you have to attach the other pieces like programming or deployment of the products that Khalid just mentioned. And then, learn Python or R. They are both equally good for statistics, but Python, it has kind of an edge in terms of web development, in terms of apps development. It has been around for a longer time, so there are more libraries attached to it. This is just my personal opinion. Somebody else might differ it. And then, how do you actually build on the skills that you already have and, starts from the basics? So I did quite a bit of research on it, and I thought, professional certificates, they're offered both by Coursera or edX. If you pick those, they start from very basics. Like the professional certificate I took at Coursera, it started with the course called What is Data Science? And then, it moved on to, okay, what are different stages of project of data science? Then Python only for visualization, then Python only for data wrangling, then Python only for machine learning. And then they gave us a capstone project where we used all whatever we had learned to apply it. And, it was just a gradual build up on things. I really like those, like that. Then build a portfolio of data science projects. As Khalid and Sushma were mentioning, the more you can show up front, obviously it's better. Then they know what our candidate is capable of, what kind of jobs we can assign to him, where he can be best fit if there are multiple roles in the same project. So it's always a plus, a big advantage. Then, if you don't already have it, pursue a master in quantitative field. You will see that, data science postings, job postings, they are always asking PhDs, master degree holders. So if you don't have it already, just join it. It will be good. It will be icing on the cake, on the skills that you already have. Then networking, whatever you do, other people should know it, and you can convey it better to the people actually who who you talk to. So, try to increase your professional network. There is LinkedIn available. Yogi Shells, he's an IT professional in this field for like more than 30 years. And when I was just new to data science, I was taking my certification. I asked him one day for his advice. How can I improve my network? And he said, what is your current number of contacts in LinkedIn? And I said, it's around 400 to 500. He said, okay, the challenge for you is to make it 1,000 and try to do it in a way that people who you are adding, your new contacts, they're either your first contact, second contacts or third contacts, but in the space of data science, in IT, that will help you a lot. And I can see that, I see all the posts, that are related to data science. And, sometimes I just open LinkedIn to see the posts of data science projects. They are so motivating, and you also get a lot of tips on current use of technologies, what kind of technologies are being developed. So it's really helpful. Then the second thing is you can join social groups like Untapped Energy. Besides meeting people, increasing your network contacts, you also get to know, the real world projects. Like I remember first few presentations that I saw early in the year, they were industrial projects, the real world projects. So you get to know actually when you're doing certifications, you're just learning the processes, and now you see their implementation, and you feel kind of motivated that you are on the right track, you're learning the right tools, you're learning the right skills, you're building your portfolio. So it's really motivating, and also it's increasing your network as well. Then data marathons, again, that's another way of networking and also improving your skills. Then, it's your previous classmates, previous companies that you have worked with, or previous colleagues that have moved into data science or relative fields, and the recruitment companies like ITIQ. Today Khalid actually gave a good summary of what really employers of data science are looking for. Then building a portfolio, that is actually the main part of the project. And, whatever I'm trying to mention here, it has already been emphasized by two people that have spoken in this presentation. So I will just move on to the project of the stages of the project. So the first one is, like business understanding. You need to understand the background. The more understanding you have about the business, the better you will be able to realize what problem you are solving, what are the parameters that are affecting it the most. How can you make a good use case and propose a solution out of that? And what kind of tools you will need to address the issue that you have. That's where the training is handy. They actually teach you different tools and what they can do. So the training is really helpful in that regard. Then data exploration and quality assessment. Again, it goes back to how well you have understood the business and what depth you have digged in to finding the solution. So that will help you in data exploration and its quality assessment as well. So, like outliers identification, you are looking at the data, but if you have the understanding where the data can be wrong because you know how the business is working and what are different criteria set by the business. So that can help you in the data quality assessment as well. So business analysis is the key. Then data wrangling and transformation. Again, it goes back to how well you have understood the project and the business understanding of that. Then feature engineering, again, it actually justifies that 80% of the time that data scientists spend is understanding the data and the business itself, because it's helping you in all the stages until feature engineering. It's all about business analysis. Then the modeling part, again, that's where the training comes handy. What kind of models can I use for this particular problem? Obviously you cannot use a classification model to solve continuous parameters issues. So that's where differentiation happens, just because of the knowledge that you have previously gained through your training. Then what are the different tools of evaluation? You can pick different tools, like R-squared for linear regression is a very simple example. So again, it goes back to how well you have understood the business and what are your models criteria, what kind of models you have picked, and then corresponding to that, you pick the evaluation criteria. And then, the deployment of the data projects, that what Khalid emphasized a lot today, how you are presenting your results. I also heard from a couple of my previous colleagues that data science job is actually expanding a lot. They are looking for like all-in-one solution. So the more skills that you can develop through different stages of your project development, the better it is. And how to summarize those results. Again, that's where the visualization come handy. And if you are able to tell a good story with the data that you have analyzed and processed and reach the conclusion, that can be very impressive for the employers. Okay, the project that I have worked on, it's actually predicting the power output. And I thought it can be very handy being an engineer. I already have some background. So I will tell you how your background can actually help in the initial projects that you take on to build your portfolio. So the first part of my presentation, I've already actually addressed those. It's kind of business presentation. You are making actually a use case out of the data sets and the problem that you have been given. And then you are presenting your solution, and how you are presenting it. I will show you the demo of the project that I have created. And the second part of my presentation is about data science architectural choices, its exploration, then the model performance indicators, and then I will move on to model algorithm. So related to the business understanding, so you are predicting the power output of a combined cycle power plant. So you need to understand what are the parameters that are affecting the power output. So here you can see that there is a, okay, let me make it smaller. So you can see that there is air and gas coming from the right side into our gas turbine, and then it's being burned there and running the blades here. And there is a steam gen here, the generator here that's producing the power and giving it to the transformer, and then it's going to the electrical lines. And then, the flue gas that coming out of turbine, it actually goes to the heat recovery steam generator that's recovering all the heat from the flue gas and creating steam. And that steam is coming to the steam turbine, and it's actually running the blades in the second generator, and that's also giving it to the transformer here. So the goal is to, how to determine the parameters, that are actually affecting the power output. So the ambient conditions in the gas turbine, like pressure, temperature, and humidity, that are affecting the load in the gas turbine section. And on the steam turbine, it's actually the vacuum pressure. So how, now you have kind of figured out these are the parameters. So now you have tried to, you have to utilize these parameters to come up with the power output, the power forecast for this plant. The other thing is, again, it goes back to the business understanding. It's actually, I took the real world data of California grid, and you can see that, here there is a power forecast in the aqua blue line, and then there is blue lines in dotted lines, that's the forecast. And then there are multiple resources that are contributing, like gas generated power. It's like making like 40% of the contribution. And at different times of the day, it's contributing differently. It's less in the beginning of the day, and then it just picks up. And the same thing is happening with the renewables. So it's low in the beginning, and then it picks up in the later part of the day. And then here you can see that this light green line is declining again. So now the challenge is, you have to meet this demand that's forecasted here. And at the same time, your supply resources, they are contributing with in different proportions in different parts of the day. So the power output forecast is actually helping you manage it both economically and meet the consumer demand, because different resources obviously are costing the power grid differently. And, so you have to make a judgment, okay, I'm dealing with a very important parameter. And now what are the parameters that I can play with to come up with the solution? So I've talked about this business problem and its understanding already. So I will move on to the data set that I have used is, it's actually a UCI machine learning repository. And there are like 9,000 records in that. They consist of atmospheric temperature, then vacuum pressure, then atmospheric pressure, and the relative humidity, the parameters that have been identified before. So the forecast, so what it will really help is actually better management of the consumer demand. It will help us decide the most viable option economically to meet the consumer demand. and the better management of the power shortfalls from other resources. Okay, so the results, I ran the linear regression model, the random forest regressor, and decision tree regressor. And the best results, in terms of R squared that I came up with was with the random forest regressor. And from that, I understood that, okay, the data is following kind of a linear pattern because of a high R squared value. And I used that understanding in the neural network that I created. I'll share with you guys. So for the neural network, I used a different number of features and different number of layers and different numbers of loss functions. And I came up with this R squared value, that's the best with the true number of hidden layers and with the mean squared error loss function. And still, you can see that it's probably performing worse than the regressor, the linear regressor, or random forest. But it's probably because the data is more inclined towards linearity. That's probably the better solution, or maybe I need to optimize my neural network better. So the data product that I want to share with you guys, it's actually a machine learning app. Are you guys watching my screen now? So I have built this app to learn the forecast of the power output. So what is the input that it's taking? The linear models that I have created is it's a linear regression model, decision tree regressor, and then the forest regressor. So you can pick any of these models, and then you can input the parameters. And on the back end, I have deployed all those models with the machine learning. And I'm giving these values, and on the back end, the processes that have been developed will calculate the forecast for the power output. So, I've just put just to give you the ideas, the ranges for the temperature. So you can give it like 30 degrees C temperature, then vacuum pressure of like maybe 50. And then if you give it atmospheric pressure, that's maybe, let's say, 1,000 millimeter of Hg, then relative humidity, maybe around 50%. And then from here, based on the machine learning algorithms, say predict power output, but you have to select the model first. So I'll just pick a random forest regressor. And, based on that, it has calculated the random forest power is 439.91 megawatt. And that's how it can be plugged into the overall management of the grid. So, what are the architectural choices? So again, it goes back to your understanding of the technology. So, what kind of data you are dealing with, what you really are looking from the data, what is the size of the data. After the data wrangling, are you deploying it on another analysis tool that you are using the libraries from for the data exploration and visualization and transformation? For my case, it was Apache Spark that I have to move my data to. And then I use the libraries for Apache Spark library, like PySpark and Spark SQL for data exploration. And then Seaborn and Matplotlib that were used for the visualization. And, on the modeling side, I use Spark ML again for the linear regression tools, and Keras for the neural network. Okay, so now, Lida showed you, this data statistics. So how you use it, it's again goes back to your statistical understanding. Standard deviation can tell you how your variables are spreading across the mean and what are the minimums and maximum that can help you analyze, about the outliers and in those, in that space. So learning these statistical concepts can be handy. That's what I wanted to mention here. So again, the relative humidity, it's more than 100%. So if you understand the business aspects, about the data, you can make a call, oh, this value looks out of loop, this is a relative value and it's more than 100. So you can dig further into it. Then, again, visualization of the data in terms of different models. The box plots is a very handy visualization tool. It can help you analyze the number of outliers based on the distribution of the data. And, that's, again, the training and the experience and your portfolio development can take you to that stage where you understand these concepts and deal with these tools and visualizations. Again, this is another way to look at your data. You can see that, which parameters are correlating the most with your target parameter just by linear visualization of the graphs. And again, the my model concepts and, the how your data is distributed will help you decide, about which features you will put in as input parameters and which parameters, you can just leave behind in your model. It can save you time in the running of the models and also in the tuning of the models. So here, the parameters that are less related, like atmospheric pressure and relative humidity, that are like normally distributed, and other ones are like binomial. And again, the outlier detection, again, that's where your statistical understanding will help you, how data outlier removal methods are working. So here you can see that, it's actually based on a threshold value of 3 and -3, and it's actually how many points your data is away from the mean in terms of standard deviation. That's what the Z factor is. So statistics and math understanding can help you here. Yeah. Again, the second method that I have used is this IQR score method. Again, that's based on statistics. The interquartile range method. You need to understand, different quartiles in the data, how you can utilize it to your maximum advantage. This is the correlation matrix. Again, here you can quickly realize, which parameters are correlating more with your output parameter, like production output. That's what we are forecasting, and which parameters are less effective. So you can decide, okay, how many factors are there or how many parameters are there in the feature engineering section. Then linear regression, again, you need to understand, what are the parameters that I'm choosing and how they are working on my model in its development, in its tuning. This hyperparameter tuning, it's actually very important. It's not about the data. It's actually how you are building the pipeline and setting the tuning parameters. It's very important to understand as well. Then, the neural network, that's a deep learning tool. It's also very handy to understand. You are just giving the input parameters, and input layer is based on the number of parameters that you have. You just select the number of neurons based on that. And then further layers are selected based on, the capability of the tools that you have. Then the input layer, the output layer is just one, because we just have a single output parameter. That's the power output. And it's linear because I'm looking for kind of a correlation from this neural network in the end. And again, different parameters that are going into the model. So you need to understand each and every parameter, what they are doing, what are, the activation of hidden layers, that's very important, how you set it up. Again, the optimizer that you are using, the loss function that you are setting. And then, learning rate and loss curve, that's the tuning of the model. So I just wanted to put an example how you are actually tuning the model based on your statistical understanding and how you are actually visualizing the data. So I'm just giving different learning rates and the output based on the loss function. Loss function is the error that you have in the data. And you can see that as we are increasing the learning rate, it's actually, the model is improving. So by showing you all these slides, I just wanted to emphasize, training is important, building portfolio is important. It's actually helping employers to look at you as a good candidate who has all the skill sets, from statistical understanding to development to how you are presenting your product. It all matters.